More examples on differentiating log functions. So here's one here. Differentiate y equals log to the base e of x squared root x. So look, we could look at this two ways. We could use the log laws. So this would be log to the base e of x squared plus log to the base e of root x. And before we differentiate that, we really need to write the root x as log to the base e of x to the half. That will help us with the derivative. So therefore dy dx is, remember this is ln, so on your formula sheet, if y equals ln function of x, then y dashed is f dashed x on fx. That's what's on your formula sheet. So just applying that rule, the derivative of x squared is 2x over the function is x squared plus the derivative of x to the power of a half is bring the half to the front, write the x out, drop the power by 1 over the original function, which is x to the power of a half. Now, so we've got 2x on x squared, which simplifies to 2 on x, plus, now I can bring this x to the power of a half down to the denominator, so I've got 1 over 2, so the 2 can go down there as well. I've got my original x to the half, and if I've got x to the power of negative a half on the numerator, I can bring it to the denominator as x to the power of a half. So I get 2 over x plus 1 over, now x to the half times x to the half is x to the 1, so I get 2x. Now I could make a common denominator by making the denominator of this 2x as well. So I would get 4 over 2x plus 1 over 2x, which gives me 5 over 2x. Now, this is a complicated way of doing this. There is a far simpler method, which we will look at now. So, a better method would be, so I'll write the question out again, log to the base e of x squared root x, is just to write this here as log to the base e of x squared times x to the half, and just simplify this before I start. So that is log to the base e. Now x squared times x to the half, that's x to the power of 2.5, which is x to the power of 5 on 2. And now we're only differentiating this one function. So dy dx will be, remember your rule, if y is ln function of x, then the derivative is f dashed x on fx. So we write the derivative of that, which is 5 over 2, bring it to the front. Write the x out, drop the power by 1 over the original function, x to the power of 5 on 2. So, now, remember we're subtracting here. So, when bases of the indices are the same, when the bases are the same, you subtract the indices. So I've got 5 on 2 times x to the 3 on 2 minus 5 on 2. I'm subtracting these indices, so I've got 5 on 2 times x to the power of, that would be negative 1, because that's 1.5 minus 2.5. So if I've got x to the power of negative 1, that is an x just on the denominator. Or you could think of it as 1 on x, which just puts my x on the denominator, so it's 5 over 2x, which is what I had before. Now, either method requires you to have a good knowledge of your index laws, okay, and also with this first one up here, knowing those log, your original log law there, where you're separating it out. So either method is fine. Okay, they're both probably a little bit tricky. Okay, now, if you look at this function, it is of the form y equals e to the function of x. But I know that this function of x is comprised of two functions. So therefore the derivative is f dashed x times e to the function of x. So what we're really going to have to do, so just break it down to what type of function it is, and it is e to the function of x. But the thing is, in this case, our function is a bit complicated. So my function of x is 2x times log to the base e of x. Now I've got to find the derivative of that function. Now this, you've got two functions in x here, so you have to use the product rule. So I've got u times v dash plus v times u dash. Now your u is 2x. So you might want to have some extra room. Your u is 2x. Your u dash is 2. Your v is log to the base e of x, or just ln x, and your v dash is 1 on x. Okay, so just being careful with that. Look, I'll write log to the base e of x, that's fine. So u times v dash, so that's 2x times 1 on x, plus v is log to the base e of x times u dash is 2. Now simplifying this, the x's cancel, and I've got 2 plus 2 log to the base e of x. So that is my derivative. Now I can simplify that and take out 2 as a common factor. So I've got 2 bracket 1 plus log to the base e of x. So now I can go back and finish off my derivative. So this is of the format e to the function of x. So my derivative, dy dx, is f dashed x times e to my function of x. Now my f dashed x is what I've just worked out here. So it's 2 bracket 1 plus log to the base e of x times e to my function of x is just that, times e to the 2x log to the base e of x. Okay, now I think you can just leave it like that. That's fine. But that one is a bit tricky. The important thing with this one is that you realize that it's e to the function of x. So define what your function of x is and differentiate it. And in this case, we had to use the product rule for the derivative of your function of x. So you just need to be very systematic here and very clear about what you're doing. Just another one. Okay, so here is another question. Differentiate this. So just again, looking at your indices. So this one should be fine for you. Just remembering your rule that you would split these up with a plus log to the base e of x plus 2 cubed. And before you can differentiate the cubed root of x, it's x to the power of a third. And this one, you could actually bring that 3 to the front. And I would be doing that too. So otherwise it's going to get complicated for you. I would definitely bring this 3 to the front because remember that is one of our rules, that log to the base a of b to the x, so it doesn't matter which one pronumerals I use, but the rule is it's x log to the base a of b. So please bring that 3 to the front, otherwise you're going to find the derivative quite complicated. Okay, so now you can differentiate. So that's still y, so dy dx is. Applying your rule, we know that if y is ln of function of x, then y dashed, or the derivative, is f dashed x on fx. So you're going to have to do that for each one. Now the derivative, so we want the derivative over the function. So if you differentiate x to the third, you get 1/3 x to the negative 2/3. Remember bringing that to the front, writing the x out, dropping the power by 1 over the original function is x to the third, plus 3 times the derivative of x plus 2 is 1 over the function is x plus 2. So we've got 1 over 3. I'm just going to keep this x to the third on the denominator and bring the 2/3 down with it. Plus this becomes 3 over x plus 2. And we're nearly there. Now x to the third times x to the 2/3, the bases are the same, so you add the indices. So we get 1 over 3 x to the power of 1 plus 3 over x plus 2. And look, if you want, that's just 3x now, so I don't need the 1. So if you want, you can go common denominator if you want. Okay, so I would just go that I've got x plus 2 plus 3 times 3x over my common denominator would be 3x times x plus 2. And you can simplify that to x plus 2 plus 9x. That would be 10x plus 2 over this denominator of 3x, x plus 2. Okay, so that is the derivative of that. So quite an unexpected result actually, that it's I suppose so simple. Another one here, last example. We've got g of x is log to the base e of x squared times e to the power of x minus 1 over e to the power of negative x plus 1. Here you've got to use, these would be addition, so we've got x squared plus log to the base e of e to the x minus 1. And then we use subtraction, so this is my numerator, this is my denominator, minus log to the base e of e to the negative x plus 1. Okay, so we can, first thing, we want to use the log law. So we've got log to the base e of x squared. This 2 can come to the front, so we've got 2 times log to the base e of x, plus we'll just keep these two the same, log to the base e of e to the power of x minus 1 minus log to the base e of e to the power of negative x plus 1. So now we need to differentiate each of these. Remember the rule that if y equals ln, or log to the base e of x, of function of x, sorry, then y dash, or dy dx, is f dashed x over the function of x. So using that now, so we've got 2 times, now this is ln x, also we know that the derivative of log to the base e of x, or ln x, the derivative of that is just 1 on x. So the derivative of x is 1 over the function of x is x. So it's 2 times 1 on x. That's our first term, plus the derivative of e to the x minus 1 is just e to the x, because when you differentiate e to the x, you get e to the x. When you differentiate minus 1 or negative 1, you get 0 over the function e to the x minus 1, minus, now the derivative of e to the power of negative x, that is, so we know that if y equals e to the function of x, the derivative of that is f dashed x e to the function of x. So remembering you need to use all these rules, I would have my formula sheet in front of me. Okay, so remembering we're differentiating, so when you differentiate the log, it's the derivative over the function, so I have to differentiate this. So to differentiate e to the negative x, that's e to the function of x. So it's the derivative of the function, so the derivative of negative x is negative 1 times e to that function, so times e to the negative x. So that's the derivative of just that. The derivative of plus 1 is 0 over, here is my function, e to the negative x plus 1. So please be very careful with this one, because remember the derivative of the log to the base e of a function is the derivative of that function over the function. So we've put over the function, but we have to differentiate this. Now the derivative of e to the negative x, we use this. So it's the derivative of negative x, which is negative 1, then e to that function, but when you differentiate plus 1, you get 0, which is why I don't have another term here. Okay, so what I've got is 2 times 1 on x is 2 over x plus e to the x over e to the power of x minus 1. Now, take away negative is plus, and that becomes a plus e to the negative x over e to the negative x plus 1. Now, we could write this with a common denominator. Okay, so if you look at what my common denominator will be, it will be x times e to the x minus 1 times e to the negative x plus 1. Please, these are not differences of 2 squares, because this is not of the format a minus b, a plus b, because this is an e to the negative x and this is an e to the x. Okay, so what is this missing? This is missing an e to the x minus 1 and an e to the negative x plus 1. So this would be 2 times e to the x minus 1, e to the negative x plus 1. This term here is missing the x and the e to the negative x plus 1. And the last term, this last denominator, is missing an x and an e to the x minus 1. So times x times e to the x minus 1. So just being careful there. Now we'll want to expand and collect like terms. Be careful here, just keep this 2 here, expand these. So you've got bases are the same with the e's, and you have to add the indices. So x plus negative x, well, that's x minus x is 0. Plus we have e to the x minus e to the negative x, take away 1. So plus, now it's x e to the x times that. So we've got x. Now e to the x times e to the negative x is e to the 0, because you've got to add the indices of x and negative x. So x plus negative x is 0. Plus, again, e to the x times 1. It'll be x e to the x. Plus, we've got x times e to the negative x times e to the x. So it's this times that. Again, the negative x plus x is 0. Minus this times negative 1 will give me minus x e to the negative x, all over the denominator, x e to the power of x minus 1, e to the power of negative x plus 1. So again, we're going to have to expand here. So I've got e to the 0, remember, is 1, so it's 2 times 1 is 2, plus 2e to the x, I'm expanding, minus 2e to the negative x. 2 times negative 1 is negative 2. Let's see, looks like we've got plus, now x e to the 0, e to the 0 is 1, and e to the 0 is 1, so it looks like plus 2x. I'll just write it as 2x, because e to the 0 is 1. And then we've got plus x e to the x minus x e to the negative x. So be careful here. E to the 0 is 1, so I've got plus x, which is plus 2x there. Sorry, can't see that very well. Okay, all over x e to the x minus 1, e to the negative x plus 1. So now looking at combining like terms. So what I did here, I expanded. Remember, e to the 0 is 1. Okay, so we had 2 plus 2e to the x minus 2e to the negative x minus 2. These two made plus 2x, and these two could not be simplified. So combining any like terms, I've got 2 minus 2 is 0. I've got 2e to the x. So remember, this and this cancels. So I've got 2e to the x plus x e to the x. I'm just trying to put the similar ones together. And I've got minus 2e to the negative x minus x e to the negative x. So I'm just putting these two together, and I've still got plus 2x here over this. Now, I could do some more factorizing on the numerator. I could do on the numerator, wait a sec, one of these isn't written out right. I've got 2 to the e to the x plus x e to the x, that's a normal one. Okay, and then I had minus 2e to the negative x minus x e to the negative x, that's right. So that was a positive x. So e to the x is a common factor between these two, and I've got 2 plus x. And e to the negative x is a common factor, but I've got a negative in front of those as well. So I go minus e to the negative x, and I've got 2 plus x again. So if I take out the minus e to the negative x and the minus e to the negative x, I will be left with 2 plus x and plus 2x over x e to the x minus 1, e to the negative x plus 1. And actually what I can do with these two is that 2 plus x is a common factor of those two. So I've actually got 2 plus x times e to the, so that's a common factor. Factorize these out. Then I'm left with e to the x minus e to the negative x plus 2x over the denominator. X e to the x minus 1, e to the negative x plus 1. Now I know that's quite involved and a bit tricky. Okay, but you can see just by making a little mistake how it would just change the whole answer and outcome. Just a few harder examples towards the end of the exercise. Differentiate the following. Y equals the square root of log to the base a of x. So that would be the same as log to the base a of x. Now the whole thing is to the power of a half. The x is not to the power of a half, but the whole thing is to the power of a half. So please be careful. That is very different. It is not the same as this. Okay, those two are not the same. So this is different. This would be log to the base a of x to the power of half. That's what that would be. And then you would be able to bring the half to the front. And then you could differentiate that, right? So these two are very different. So this is what y is. So the derivative, is you want to use the function of a function rule, so I'd bring the half to the front, write out log to the base a of x, drop the power by 1, and then times by the derivative of log to the base a of x. So remember your formula sheet with log to the base a of function of x, this is on your formula sheet, then y dash, or your derivative, is f dashed x over ln a function of x. So that's on your formula sheet. So in this case, so again, we put the half to the front, we've written this out, drop the power by 1, times the derivative of log to the base a of x. So the derivative will be f dashed x, so the derivative of x is 1 over ln a, and the function of x is x in this case. So what we've got is 1 over 2. Now, because this is to a negative power, we can write it on the denominator. So I'll write it like that, times 1 over. Now it's best to put the x in front, so it's x ln a, otherwise it'll look like ln ax. So now, remember, this is just a square root. 1 over 2 times the square root of log to the base a of x times 1 over x ln a. Okay? Just to make it look a bit tidier, you could put the 2x ln a at the beginning times the square root of log to the base a of x. Okay? And we'll just look at another question. Let's look at something like 15e, which again is the square root of x a to the power of x. Now remember, you could do this a few separate ways. If we have to differentiate that, that really is x times a to the power of x all to the power of a half. Now, if we know that they're both to the power of a half, you can take the power of a half of both of those. So that's x to the power of a half times a, and x times a half is a half x, or x on 2. So that is actually what you can differentiate. Now that really is x to the power of a half times a to the power of 1/2 x. Okay? If you actually look at your formula sheet, you'll realize we're stuck. We can only differentiate a to the x, not... Oh no, we can do a to the function of x, sorry. Yes, we can differentiate a to the function of x. So just looking at your formula sheet, if y equals a to the function of x, then y dash is it's ln a f dashed x a to the function of x. So always please just refer to your formula sheet, because sometimes you might think something's not possible, but it is. So that's on your formula sheet. You can see here y equals a to the function of x. The derivative is ln a f dashed x a to the function of x. Alright, this is one method for doing this. We could do it another way, and we'll have a look at that other method in a minute. Alright, so here we would use the product rule. So u would be x to the power of a half, u dash is a half, x to the power of a negative half. V would be a to the half x, or x on 2, and v dash, so we're going to have to use this, is ln a, the derivative of a half x is a half, and then we've got a to the function of x, which is x on 2, or a half x. I'll write it as x on 2. So that is ln a on 2 times a to the x on 2. Okay, that's what that derivative is. So the derivative is the product rule, uv dash plus vu dash. So it's u times v dash. So it's x to the half times ln a on 2, a times x on 2, plus v times u dash, which will be a to the x on 2, or half x, it's the same thing, times 1/2 x to the power of negative a half. Now this is all looking a little bit complicated, but we do have a to the power of x on 2 as a common factor. So let's pull that out. A to the power of x on 2 is a common factor. There and there, we're left with ln a on 2 times x to the power of a half. plus a half, and this is x to the power of negative a half. Because we've just taken out the a to the power of x on 2 to the front. Sorry, I thought I was recording, but I wasn't. So remember, this is a to the power of x, or to the power of a half, because x on 2 is x times a half, okay? Because I want to write it as a square root. The reason I want to write it as a square root is that the original question was written with square roots. So I'm separating this x on 2 to be x times a half. Then I'm just writing this x to the power of a half as a square root. So ln a on 2 times square root of x plus 1 over 2. I'm bringing this x to the half on the denominator, which is really just root x. So then what I'm going to do, what we're doing here is, we know the power of a half means square root. So this is the same as the square root of a to the x times ln a on 2. Sorry, look at these two fractions. The denominator is not the same. So you want to be multiplying this first fraction by root x over root x. So I've got ln a root x there times root x, which now gives me a denominator of 2 root x, plus this one already had the denominator of 2 root x. Now I've got root x times root x is x, ln a plus 1 over 2 root x. Look, I know this is tricky, but this would be harder. Okay, this is harder. You know, probably more suited towards the very end of a paper, or even for extension. Okay. Probably another way to do this that might be a little bit easier would be to write this as y equals x a to the x all to the power of a half. And then you could say, right, the derivative is to bring the half to the front, write this out, drop the power by 1, times the derivative of what's inside. But we would have to use the product rule for the derivative of what's inside. So this is just another way to do it. So if you want to use the product rule in here, u is x, u dash is 1, v is a to the power of x, v dash is ln a, I believe a to the power of x. Because remember, it's ln a, the derivative of x is 1, so, and a to the x, if you just go back and look at your rule. So if I was to apply the product rule here, times uv dash plus vu dash. So remembering, we're bringing the half to the front, we're writing this out, we're dropping the power by 1, times the derivative of what's inside. But the thing is, what's inside is a product, so you would have to apply the product rule inside. So this would be 1 over 2. Now this is all to the power of negative a half, so I could stick it all on the denominator. So it's x a to the power of x to the half times the derivative. Now it's u v dash, which is x times ln a times a to the x, plus v times u dash is a to the power of x times 1. Okay, so what we've got, this would all be on the numerator, because this fraction is multiplied by that, so it's all on the numerator. So I've got x ln a times a to the x plus a to the x over 2. Now both of these are to the power of a half, so I'm actually going to write them separately to the power of a half. So it's x to the power of a half times ax to the power of a half. Now what we can do here, we've got two terms and we've got a common factor of a to the power of x, and then I've got x ln a plus 1 over, now this is 2, x to the half is root x, and ax to the half is the square root of ax, and we're nearly there. Now, or I could even just leave it as ax to the power of a half, because we know that. So here I've got a to the x over the square root of a to the x. Well, that's just the square root of a to the x, because this is a to the x over a to the, this is x to the power of a half. So that is actually a x to the power of a half, or a to the x on 2, or half x. So you do, the bases are the same, so I'm just rewriting that. It's, you do x minus a half x is a half x, so it gives you square root. Or, if you're finding that a bit tricky, for example, if I had, for example, 3 over root 3, so I've got something over the square root of itself. Well, 3 over root 3 we know is root 3, because 3 happens to be root 3 squared. So that's root 3 squared over root 3 is just root 3. So this a to the x over the square root of a to the x simplifies to just square root of a to the x. Then we're left with x ln a plus 1 over, now I've simplified those two, over 2 root x. Okay, and that is the same answer as we had over here. Okay.